Hello, friends. Welcome to Science Talk. I'm your host, Jim Assa. In another article appearing on the online publication, The Energy Mix, Ocean Warming Drives Need for North Atlantic Carbon Observatory. Okay. And a picture of some little cetaceans. Nice little wave action. Warming oceans may be absorbing less carbon dioxide than they used to, and scientists say it could have serious ramifications for climate targets. Well, geez, what have I been saying for several years now on this channel? That gas solubility decreases with increased water temperatures. We're warming the oceans. They're not going to be absorbing as much CO2. And eventually, especially if you get to equilibrium, then on the other side of equilibrium, you could have what? You could have the gases begin to outgas from the water back into the atmosphere, further increasing the levels of gases in the atmosphere, further increasing the warming. So there, we get screwed no matter what. So they go on to say more research is desperately needed on the impact of climate change on the ability of the world's ocean to absorb greenhouse gas emissions, said Anya Wade, Scientific Director, Chief Executive Officer of the Ocean Frontier Institute Research Partnership. Climate targets actually haven't been taking into account the ocean. Let me highlight that there for you. Climate targets actually haven't been taking into account the ocean. What is one of my major criticisms of the ICPP? They just basically give short shrift to the oceans, to methane, whatever. Remember, the oceans have absorbed 93% of our greenhouse gas emissions, heat, carbon, what have you, over the last 50 years. 93%. It's just that other pesky little 7% that's doing all the shit that we're experiencing lately. So there is, the latest estimates I'm seeing now is up to 240 zettajoules of energy in the oceans now, down to 2,000 meters, with the great majority of that concentrated in the upper 500 to 700 meters or so. That's a shitload of energy waiting to do something. And as you warm the surface water, you're going to basically, slow down the thermohaline flow. You're not going to sequester that material to depth. It's going to stay in shallow layers, and that's a bad thing. And we urgently need to take the ocean into account, or we won't be able to reach climate targets. In fact, the targets themselves may be wrong. Yeah, 2C, well, look at 1 point, officially it's 1.2, it's actually higher, but look what that is already doing. Oceans that are no longer able to absorb carbon may become carbon emitters. Just like the Arctic is becoming a carbon source, no longer a sink. The Amazon also becoming a carbon source, no longer a carbon sink. Guess what? That's where the oceans are heading to. They're headed to becoming a carbon source. Now, this WAIT is trying to put together a North Atlantic Carbon Observatory, which could possibly unite scientists and researchers from around the planet to better monitor the problem and find a solution. The ocean is the most important global carbon dioxide storage depot on the planet, absorbing more CO2 than all the rainforests combined. 40% of fossil fuel emissions have actually ended up in the ocean. That value is incorrect. It's 93%. About 30% of that absorption happens in the North Atlantic, making the most intense carbon sink on Earth. And that's because you got Europe right there, it's the high population density, and you've got North America right there, another high population density. That kind of makes sense. Darlia Adamanchuk, a Nova Scotia-based researcher with the Institute, said it's possible because of the North Atlantic's staggering depth, swift currents, icy temperatures, cold water holds more carbon. Yeah, gas solubility is inversely proportional to water temperature. And deep water can store it for centuries. Not if the vertical flows are slowing down or stopping. And we're seeing evidence that that is indeed happening. This carbon is being drawn to like 2,000 or 3,000 meters, and it stays there. Okay, kind of need to put a little qualifier on that. It stays there, not permanently. It may stay there for centuries, depending on the flow rate and so on. So it can eventually make its way back to the surface. In fact, the Antarctic divergence zone is where a trunk of the conveyor belt does indeed make its way from 2,000 meters to the surface, upwelling, bringing nutrients with it that helps fuel the Southern Ocean ecosystem there. And that means it's bringing the carbon back up with it. The oceans and the atmosphere interact in concert, always aiming to balance carbon dioxide saturation. If the air holds more of the gas than the ocean will absorb it. As ocean temperatures climb, currents slow down, the gas could flow the other way, and it will if the current trend continues. And they say looked at for as an example the Labrador Sea. There's clear correlation between the increasing anthropogenic carbon in the atmosphere from fossil fuels and a parallel increase in how much carbon is stored in the Labrador Sea. As an example, the same process would be true just about anywhere. If you measure what's happening to carbon in the North Atlantic, it's a good measure for the bigger picture of the global pattern. A North Atlantic Carbon Observatory will be a first step toward truly integrated, coordinated ocean carbon measurement that can basically bring a whole bunch of folks together, find out what the hell's going on. Well, you know what? It might already be too late. But anyway, sure, get the data. I have no problem with that. Get the data. Figure this out. If time doesn't run out on us, figure this out. The more information we have, the better. Increases our understanding. But the point of things being said here are the things I highlighted. That warming ocean is not going to hold as much CO2, and then the CO2, if you keep increasing the temperature, you go past the saturation, that CO2 or whatever gas it is goes back into the atmosphere. So, and we do know that vertical flow, which helps sequester to depth the CO2, is slowing down. So the sequestration will be slowing down, which means more of that stays in the shallower depths. Well, what's not addressed here is that if you increase the CO2 levels there, your basic CO2 plus water makes carbonic acid. You're going to do what? You're going to start lowering the pH. These acidity increases. That is detrimental to organisms that have shells. Because literally the lysocline will get shallower and shallower, which means that the calcite will have a tendency to stay in solution. So these organisms have what happen to them? Their homes dissolve out from around them. In the shells of their homes. So there's that issue as well, which they didn't discuss here, but really is part of the problem. And therefore, we need to understand better the chemistry of that, and of course the physics that drives that chemistry. So Want to set up a carbon monitoring system? Fine, go for it. You know, anything that helps improve our knowledge. So, there you have it. Let's see if they're able to implement this system. We'll talk later. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.